August 18, 1913. The roulette wheel at the Casino de Monte Carlo spun, and the ball dropped into a black slot. Then it happened again, and again. 26 times in a row, the ball landed on black. The odds of this sequence occurring on a single zero wheel are roughly 1 in 68.4 million. Gamblers crowding the table lost millions of francs that night. They fell victim to the gambler's fallacy, the cognitive error of believing that statistically independent events owe the universe an immediate balance. Because black had hit so many times, they assumed a red outcome was mathematically due and bet heavily against the streak. This historical reaction highlights a universal human instinct. We treat luck as an invisible, manipulable current flowing through the cosmos. Across cultures and millennia, people have developed specific rituals, worn amulets, and relied on certain numbers to harness good fortune and banish bad outcomes. Modern physics does not support this worldview. When subjected to the scientific method, the natural world reveals absolutely no physical mechanism, energy field, or conscious intent designed to dispense fortune to one person over another, which leaves a difficult question. If luck is not a real property of the physical universe, how do we explain a 26-spin streak in Monte Carlo? Lottery winners who hit multi-million-dollar jackpots repeatedly, and seemingly impossible coincidences. Take the quintessential symbol of chance, a coin toss. From the perspective of classical, macroscopic physics, flipping a coin is entirely deterministic. The outcome is dictated strictly by the initial force applied by the thumb, local gravity, angular momentum, and air resistance. Physicists call this epistemic randomness. The outcome of a coin flip only appears random to us because we lack the exact measurements of those initial conditions. If a computer tracked every physical variable, it could predict the landing with absolute certainty. True unpredictability only exists at the microscopic, subatomic level. While quantum systems exist in uncertain, probabilistic states, they possess zero conscious intent. Furthermore, these tiny systems stabilize into predictable classical mechanics long before they can rig a lottery ticket or steer a roulette ball. To understand extreme fortune, we have to look past physics and examine the mathematics of probability, specifically the law of truly large numbers. This axiom explains why an incredibly rare event feels profound to the single person experiencing it, while remaining a mathematical certainty to statisticians. Consider a specific incident with a 1 in a million chance of occurring. To an individual, that is a miracle. But in a global population of roughly 8 billion people, that exact 1 in a million event is mathematically guaranteed to happen to 8,000 different people every single day. On a planetary scale, raw, indifferent randomness generates such a massive volume of events that impossible miracles become a statistical guarantee. Our neurological hardware is poorly equipped to handle this mathematical reality. In 2003, Dutch nurse Lucia de Burke was convicted of serial murder after her hospital experienced a sudden, tragic spike in infant deaths. The prosecution's case relied heavily on a critical statistical error. An expert testified that the odds of de Burke being on shift during so many fatalities by mere chance was 1 in 342 million. They framed her as being too unlucky to be innocent, securing a criminal conviction based entirely on flawed probability. The human brain evolved to be a hyperactive pattern recognition engine, optimized to detect predators and ensure our survival. This trait makes us highly susceptible to apophenia, the psychological tendency to perceive meaningful connections and intentional designs with entirely unrelated random data. This visualization shows a specific subset of apophenia called the clustering illusion. Because our brains expect true randomness to look perfectly uniform and evenly spaced, we naturally reject these chaotic clumps as unnatural. We assume an underlying cause is directing the data. De Burke spent years in prison before independent statisticians proved the initial calculations disastrously wrong, leading to her complete exoneration. The hospital had simply experienced a natural random cluster of tragic deaths. The justice system invented a malicious pattern where none existed. While cognitive biases make us victims of probability, those who understand the math can exploit it. Joan Ginther won 4 separate multi-million-dollar Texas lottery jackpots, totaling over $20 million. The press quickly labeled her the luckiest woman on Earth. Ginther held a PhD in statistics from Stanford University. She understood that scratch-off lotteries are not purely random. They rely on deterministic, pseudo-random distribution algorithms designed to spread winning tickets evenly across geographic areas to keep players interested. By studying public shipping manifests and applying the law of large numbers, Ginther calculated the expected value of specific ticket batches. She executed massive purchases only when her analysis showed the mathematical odds heavily favored a payout. Ginther's success came from mastering the underlying mathematics of the game. By strictly separating her decision-making process from the variance of individual outcomes, she successfully neutralized luck. You do not need a PhD in statistics to alter your relationship with chance. Psychologist Dr. Richard Weissman spent a decade studying self-identified lucky and unlucky individuals in a clinical setting he called luck school. Weissman found that lucky people consistently exhibit low levels of anxiety and high extroversion. With a relaxed mindset, they maintain a wide peripheral vision, allowing them to spot subtle opportunities that hyper-focused people completely miss. This chart maps a behavioral heuristic known as the luck's surface area. It plots doing, the degree to which you master a skill or pursue a passion, on the vertical axis, and telling, effectively communicating that expertise to your social network, on the horizontal axis. By increasing the quality of your work and systematically expanding the number of people who know about it, you grow your overall surface area. You turn yourself into a massive target for low-probability, high-impact serendipitous events to strike. While the universe provides the raw, chaotic distribution of events, our own behaviors determine who captures the windfalls. Luck functions as a mathematical byproduct of how an individual interacts with chance.